what if there was a better way to make and deliver pizza to you? Turns out there is.
Fast food jobs are demanding and sometimes even dangerous, but not for robots.
The machines can look at more things faster in greater detail. They never get bored. They don't need breaks.
Boston Dynamics has made a name for itself by building robots like Spot.
We're using technology to advance the state of the art in molded fiber production, and we can do it with speed that is absolutely category leading.
Welcome to White Castle. This is Brittany. How may I help you?
This robot named Flippy runs the fry station at a White Castle outside of Chicago. With its mechanical arm and using computer vision technology, Flippy can cook everything from French fries and onion rings to cheese sticks. White Castle said it plans to add 100 Flippies to its kitchens nationwide.
We used to need 2 people to operate that French fry area during peak hours, and now we are able to only have 1 person operating that area.
Would you like to try the mac and cheese bites today? All right, thank you. If the screen's correct, it is 827. Second window, please.
Fast food jobs are demanding, quick moving, and sometimes even dangerous. But not for robots.
When you look at the restaurant industry, it's a little bit late to the party in adopting automation and robotics in particular.
So far, the restaurants that are using them or trying them out say that this automation really only has to do with helping relieve boring tasks from workers' plates, help make their jobs easier, let them engage with the customers more. But there's a lot of reports out there kind of guesstimating how many jobs could be replaced by these robots, by automation.
Up to 82% of restaurant positions could to some extent be replaced by robots. Automation could save U.S. fast food restaurants over $12 billion in annual wages. And restaurants are also struggling to find workers. American restaurants are down more than 560,000 jobs, or about 4.6% of its workforce from their pre-pandemic levels. About a third of Americans worked in a restaurant as their first job, and half have some restaurant work experience.
Yeah, the economics of this are very, very compelling. If you take minimum wage, just around the $20,000 per year mark. That's the cost of 1 robot.
Other companies in the space include Picnic, that has a robot that makes pizza, and Autech, whose machines make sushi. So what impact will robots have on the fast food industry and the livelihood of its workers? CNBC got a behind-the-scenes look at restaurant robot maker Miso Robotics to find out. Miso Robotics got its start in 2016 with a handful of engineers in a Pasadena, California garage. 2 years later, the company launched Flippy at a nearby Caliburger restaurant. Flippy's first job was turning over a hamburger patty after it was placed on a grill by a human chef. But the company quickly pivoted to fried foods, rolling out a portable fryer station for baseball games at Dodger Stadium.
This was really the peak throughput test for us. Can Flippy keep up with in-between innings at a Dodger game and everybody goes to the concession stand? Can we meet that demand?
In 2021, Miso launched Flippy 2 using a mounted rail system, AI, and computer vision technology that can identify and track food as it moves through the structure. Although it has a camera, tablet, and robotic arm, engineers say the real tech is in the software.
The hard thing to get right about this product is having the computer vision, the algorithms that plan the cook cycle, and the software that manages the robotic motion to all work together so that it's as reliable as a refrigerator and it does the job.
Food is dispensed directly from the freezer into a basket. The robot's computer vision identifies the type of food and places it in the appropriate fryer. Once the food is cooked, the basket is taken out of the fryer, shaken, and dumped into a holding area where it is bagged by a worker.
For those of us who have been in a restaurant, this is exactly the same process that is done today by a human.
He's constantly playing like a multi-frame game of chess in his mind, understanding where to be next, so his sequence of movements is precise and he doesn't undercook, overcook food.
But what about the cost? Miso charges restaurants about $3,500 a month for a Flippy 2 under its robot-as-a-service model. The company charges an additional fee of about $10,000 for installation. By comparison, the median hourly wage of fast food workers in the U.S. is just $12.07 an hour. There were roughly 11.7 million restaurant workers in the U.S. in 2022.
But Flippy 2 is different. Flippy 2 works around the clock. We have many 24-hour locations where Flippy 2 is installed. Flippy doesn't call in sick.
Built in Columbus, Ohio, it takes Miso about 6 weeks to manufacture one Flippy 2. The current off-the-rack mechanical arm is the same type designed for car factories, and Miso says they cost $15,000 each, plus another $5,000 to modify with additional grippers and sensors. Last year, Miso partnered with robotic arm maker Ally Robotics and hopes to start producing its own arm in 2023. The company also makes a streamlined version of Flippy 2 called Flippy Lite, as well as a drinks dispenser named Sippy. Flippy Lite is currently being tested in restaurants by Chipotle.
And what Flippy Lite is designed to do is to take one item that requires frying and just cook the heck out of it all day long.
With about 25,000 shareholders, Miso has so far raised more than $70 million in crowdfunding. The company's also announced it is testing a robot that fries chicken wings for WingZone. The global fast food industry is a $273 billion business, including more than 280,000 fast food restaurants in the U.S. alone. At this White Castle on the outskirts of Chicago, staff in the busy lunch hour shift face a barrage of orders coming from drive-through customers as well as the main counter.
Would you like to try any mac and cheese bites today? Oh, thank you. If the screen's corrected, it's 10:42. Second window, please.
It's very fast-paced. We're all in our positions, but we do move around, jump about to help out, to get the orders out.
But meager salaries, fewer teenagers in the workforce, and fear of COVID have been a drain on fast food restaurants. Job openings at restaurants and hotels reached 1.3 million in November 2022, the 20th consecutive month with over 1 million vacancies. Bars and restaurants make up about 90% of those positions. A typical fast food worker makes about $26,000 a year, compared with a concierge at a hotel who can earn more than $37,000.
During the pandemic, we faced a lot of staffing challenges, and things are better, but there are still challenges with staff in many locations.
To assist workers, White Castle added Flippy to take over its fry station. The robot cooks food more consistently and doesn't require time off.
And I think some restaurants are also looking at this as a way of, well, this robot is expensive, but is it cheaper than however many employees I would need to hire, especially because a lot of workers have not been sticking around as long as they're used to.
This is one of the positions that is the hardest to fill and hardest to retain for restaurant operators. There are dozens of positions back of house. This one is a really demanding one. It's hot and it's very, very fast paced.
Robots like Flippy solve other problems for restaurants too. For starters, fast food work can be dangerous. In California, the state with the highest number of people employed in the fast food industry, workers face health hazards, ranging from overflowing sewage, smoke inhalation, and extreme heat, according to one study. Turnover is another headache for the industry. Prior to the pandemic, the restaurant industry faced a workforce turnover of 130%, according to Panera Bread's CFO, Michael Bufano. At the same time, low-wage workers made up 43% of the U.S. workforce.
As you look at the labor allocation within the restaurant, that's being able to shift one human from that station somewhere else, and that's saving every single month probably somewhere around $700 to $900 in actual profit.
Another incentive for restaurants, hard-to-fill positions have forced chains to push hourly wages to new highs.
The wages have been very low in these industries. They've really been very much pegged to the minimum wage, so that when the minimum wage has been allowed to decline in real terms, that is, it hasn't kept up with inflation, then those jobs get progressively less and less attractive.
Labor is one of the biggest costs restaurants face, averaging about 25 to 30% of sales. McDonald's said it would reach an average of $15 an hour by 2024 at all company-owned restaurants. Starbucks said it was bringing its pay floor for U.S. baristas to $15 an hour. Gen Z consumers made 5 billion restaurant visits in the year ending July 2022, including 4.3 billion trips to fast food eateries. Restaurants often have thin margins, which is one of the reasons why adoption of automation has been slow. But that could be changing as the cost of robots has declined by 50% over the last 3 decades. Industrial robot usage has tripled over the past decade from about 1 million in 2010 to 3 million in 2020. The auto industry, by far the largest segment in the market, is followed by electronics, food and beverage, and metals and machinery. The industrial robotics market is expected to reach $81 billion by 2028, up from almost $42 billion in 2021. But will those trends impact Miso's business?
Robots are hard to develop and they're expensive to develop. It takes a lot of time and money and frankly a lot of engineers to get all the technology working together smoothly. Miso makes money by having more and more robots in the field.
In 2021, Miso spent $1.5 million on R&D, $7.8 million on salaries, $6 million on sales and marketing, and a little over $6 million on overhead and administrative expenses. Revenue was just $36,000 in 2021, mostly from the deployment of one Flippy.
Right now, it seems like Miso Robotics is probably the biggest and best known player in the space.
Competitors is a pretty small pool at the moment. We've been on the forefront of this for a long time, but they are coming, and we know the ones that aren't here today will be here tomorrow.
Robot adoption could come quickly, in a similar fashion to the way delivery apps revolutionized the restaurant space. The global food delivery app business is over $150 billion, triple the amount it was in 2017. And that would be welcome news for fast food restaurants who face pressures ranging from rising food costs to staff turnover. Americans spent $2.1 trillion on food in 2021, with more than half of that money going to food away from home purchases.
The tide has turned. There's no longer a question of are robotics coming to the industry. It's a foregone conclusion. The question is, at what pace and in what form?
And what you will see in the months and years ahead for the foreseeable future is more and more automation solutions like Flippy 2 being deployed in everyday restaurants, including some of the best known brands in the world.
There was a lot of hype in 2017 around Zoom.
What if there was a better way to make and deliver pizza to you? Turns out there is.
Zoom is revolutionizing delivery model. All pizzerias out there, you're in trouble.
At the time, Zoom was a pizza company that used robots to automate the pizza creation process and utilized large oven-carrying trucks to bake the pies as they traveled to customers. The idea was a hit and earned Zoom a $375 million investment from SoftBank. So why are we talking about pizza made by robots in a video about compostable packaging? That was our question too.
One of the problems that we encountered in pizza was our beautiful pizza with no stabilizers in it, in a traditional box, declined in quality from the time you cooked it to the time it was delivered, to the point where we didn't think it was good enough. So we designed a new pizza box.
At the beginning of 2020, Zoom laid off half of its workforce, 360 employees.
This is another stumble for SoftBank's Vision Fund, which invested $375 million into Zoom, bestowing that unicorn status, $1 billion valuation.
But the company kept going. Now, Zoom is dedicated to producing compostable packaging that is durable and backyard compostable, breaking down in a matter of 90 days. Zoom is breaking into the $274.2 billion sustainable packaging market, which is expected to grow to $413.8 billion by 2027. But the industry does face challenges.
I wish I could say it was just the cost, and cost is going to come down, or it's just that we need one thing, but it's really, I think, a variety of factors.
As the oceans fill up with plastic waste and as companies make pledges to switch to greener packaging, it could be great timing for Zoom. So let's take a look at some roadblocks in the compostable packaging industry and what can be done to overcome them. Let's talk about the life cycle of a package first, using a takeout container as an example. Takeout containers can be made of many different materials, which all have their pros and cons, like plastic, metal, styrofoam, cardboard, and a compostable material like molded fiber. Some plastics and metals can be recycled, but they have to be perfectly clean in order to be made into another product. They can also be downcycled, which is where they're used to create something that cannot be recycled again, like a park bench. But recycling has failed in the US. In 2018, less than 9% of plastic waste was properly recycled in the US, and it got worse in 2019 when China stopped importing American trash. So most of what you think may be getting recycled is actually getting sent to landfills, or making its way into rivers and oceans.
The UN says that by 2050, we'll have more plastic than fish in the ocean. Plastics become so prevalent that every person on the planet eats a credit card's worth of plastic a week.
Plastic recycling has actually been considered by some to be a ploy by oil companies to make plastic production seem more environmentally friendly than it is. And even sending food scraps to the dump can be harmful.
When you're actually introducing those organics in landfill, you create a lot of methane. And as you know, methane is a very important greenhouse gas emission. So then you want to reduce that amount of organics that you send it to the landfill.
But the US loves plastic. The country generated more than 14.5 million tons of plastic in 2018. It's not easy to get away from that.
Plastic's an amazing material, it's miraculous, and the convenience of plastic has powered many of the modern conveniences that we enjoy as consumers around the world. But unfortunately, the things that make plastic great come with catastrophic consequences.
Aluminum containers are a bit easier to recycle, but still only saw about a 35% recycle rate in 2018. Cardboard is recyclable and compostable, but only if it's clean and doesn't have some sort of coating on it. Virgin cardboard can also contribute to the deforestation of endangered habitats. Styrofoam, or polystyrene, is technically recyclable, but not in a way that is economically feasible or environmentally effective. Many cities and states, including New York City, Maine, Vermont, Maryland, and a long list of cities in California, have completely banned the use of polystyrene, and the trend is growing. Compostable materials seem like a solution to these recycling issues, but come with their own set of confusing marketing tactics and end-of-life difficulties. For instance, the word biodegradable, which is used to describe certain materials like plastic made from corn, has been scrutinized.
That necessarily does not mean that a bio acronym at the beginning will mean that the polymer is from bio-based resources or is biodegradable. And if it's biodegradable, it doesn't mean that it's compostable either.
The word biodegradable on its own, for a marketing term, is seen as potentially pretty misleading. So several states have passed laws actually forbidding the term biodegradable in marketing language when it comes to single-use items. So states like California, Maryland, and Washington, Minnesota for bags specifically.
Some materials require composting in an industrial facility, like certain cutlery and coffee cup lids, which means you can't just throw it in your backyard and hope it will break down. It has to be sent to a facility that monitors the chemical and temperature levels of a large compost pile. The materials are also sifted to make sure everything has broken down properly. And if you think you're doing the environment a favor buying these industrial facility compostable products and still throwing them away in the trash, you're only partly correct. Landfills are usually too compressed to allow oxygen and microorganisms to break materials down, even for things like food or paper, which are usually pretty easy to break down.
Unlike with recycling, where you have different plastic types, you have different shapes, and that can help determine the recyclability, and each community has its different requirements based on what their recycling facility can sort. There's no one common definition of what is recyclable. With compostability, it's different. We have these international standards saying this is what is compostable, regardless of what plastic type you're using, regardless of whether there's paper in there or not.
According to one report, only about 27% of the United States population has access to some kind of composting program that accepts either food waste only or food waste and some form of compostable packaging. So it's not a ubiquitous solution yet.
The real difficulty here at Zoom is finding the solutions to replace all of those arrows. Let's get rid of those arrows so that you don't have the confusion at the consumer level, you know, can I or can't I, and throw your hands up and I'm just going to throw it in the trash and let it go to the landfill. So it's going to make it simpler, easier. I know I can just take it, compost it, and 90 days later, I can use it to fertilize my garden.
Zoom developed packaging that is backyard compostable, and it really makes a difference. Backyard compostable packaging can break down without the use of industrial monitoring. They use the microorganisms in the soil or water to break down packaging. For people living in areas without composting services, this gives consumers the option to discard their waste in a local compost pile or even in their backyard compost piles.
I can tell you that we've tested our products with independent labs in all of the known waste streams, and we have all the certifications that give you the results that you'd be looking for.
Recently, compostable products have been on the rise. Companies like Full Cycle in the US, Us2 in India, and Biofasa in Mexico have been springing up left and right. Unilever and PepsiCo, among others, have goals to design 100% of packaging to be reusable, recyclable, compostable, or biodegradable by 2025.
That's partly a technical definition, so making it technically recyclable or compostable, but you also have to be able to get it recycled or composted at scale. And that's what we're all working on right now, is how do we make that happen, both technically recyclable or compostable and at scale.
And Zoom is trying to make the compostable transition easier for brands, brokers, and distributors by creating packaging out of materials that are local to the companies that need them. For some of their packaging, the materials they use come directly from nearby farms who can sell their agricultural waste to Zoom.
One of the big things I think we can do here is revamping the supply chain. So let's build a pulp mill next to the source of the agricultural waste, so it doesn't get burned or it doesn't get taken to a landfill. Turn it into premium molded fiber packaging that then is composted, so it's a place to grow the next crop. It's a closed loop supply chain, and if something I think we've heard a lot about over the past year is the supply chain.
The company has products available in 21 countries, including takeout containers, cosmetics packaging, and their robotic technology when a company wants to produce packaging themselves.
We work with some of the largest industrial companies in the world, and they build factories based on our technology. At the same time, we work with some of the biggest brands in the world, and we solve their product problems. We help give them a road beyond plastic. When we have these fully qualified products and these fully qualified factories, we connect the two of them together, and we give brands a path beyond plastic at scale with great economics for the brands and great economics for the factory partners.
The sustainable packaging industry is a $274.2 billion a year business. Of course, the packaging industry as a whole is about $900 billion, so there's still a lot of work to be done. There are some constraints when it comes to compostable packaging, like higher cost. 100 plastic straws can cost as low as $1.53 when bought in bulk, compared to paper straws, which can cost $1.67 for 100 when bought in bulk. That's an increase of 9%. These plastic clamshell containers for burgers and sandwiches can cost 13 cents each when purchased in bulk. Their natural fiber counterpart can cost 19 cents each when bought in bulk, an increase of 46%.
Remember, packaging is a commodity and it's always a low-cost product. So in general, for food or for this kind of situation, your margin is very small, that you can actually don't have a large amount of room there to have a cost in the packaging system.
Zoom says its robots are the reason it can keep costs down.
Previously, machines could either make very low-quality things quickly. Some machines could make high-quality things very slowly, but they were so expensive that they would be outrageous for a consumer market. What our technology does that's so revolutionary is it can make very high-quality parts very fast.
And then there's the question of performance. Compostable packaging companies have come up with many ways to make their products as durable as environmentally damaging alternatives, but it's not always easy.
We're using technology to advance the state of the art in molded fiber production, so we can take many, many millions of tons of agricultural waste and turn it into not plastic. And we can do that without compromising on performance or on price, and we can do it with speed that is absolutely category leading.
One thing Zoom doesn't have control over, though, is the difficulty that comes with waste management, including the lack of composting programs mentioned before, along with the general confusion of whether something is compostable or not.
The problem is that the waste management system is still at the state level. So we have 50 states with different type of goals. So we should have tried to get at least an aggregation of a state, or if the federal government can actually pass some type of legislation on where we have goals to move the whole country forward.
Without a fully circular economy, meaning packaging is created, used, and turned back into materials that can be used to create more, our packaging obsession will continue to cause problems.
There's tremendous demand for these solutions in the market and with consumers. So now that the solutions exist and the demand is there, now we're getting the scale.
You may have been one of the 140 million people who've seen this video on YouTube. Boston Dynamics has made a name for itself by building robots like Spot, which move in ways that many of us have only seen in sci-fi movies.
We look at ourselves as having mastered the ability to create robots with mobility, vision, and manipulation. And we think we can combine those in just almost an infinite number of ways at different applications.
The public's fascination with Boston Dynamics' robots is likely owned to equal parts awe and fear. A 2017 episode of the popular dystopian Netflix show Black Mirror depicted a woman running from a pack of killer robot dogs. The show's creator later admitted in an interview with Entertainment Weekly that Boston Dynamics' videos were the inspiration.
Most people think when they see Spot that that's cool. There is a small fraction of people who say it's creepy. We've been telling ourselves fictional stories about dystopian robots for 100 years. I think it's people's desire to kind of explore that fear that makes them want to react so negatively to Spot.
But while Boston Dynamics has sparked the imaginations of the general public with its viral videos, the company is now hoping to get the attention of paying customers.
I expect that we will become a serial producer of novel robots with advanced capabilities. I think we'll build every 3 to 5 years. We're going to roll out a new robot targeting a new industry.
CNBC got a rare look at Boston Dynamics' office in Massachusetts, where the team showed off 2 of the robots they're working to commercialize, Spot and Stretch.
The yellow robot that you see walking around is a mobility platform. It gets really interesting when you start adding payloads on it and integrating it into things. We have really nice visual cameras, thermal cameras, microphones, gas sensors, and those let you take the robot into interesting places and collect data about what's going on.
We see Stretch as ultimately a general purpose box moving machine that can be used anywhere in the warehouse.
Those 2 markets in particular, the robotics inspection and the warehouse market, are what we perceive to be the fastest growing market within all the robotic subsegments.
The machines can look at more things faster in greater detail. They never get bored. They don't need breaks. They're just relentless.
With nearly 30 years of experience, Boston Dynamics has proven its ability to make robots that move in remarkable ways. Now the question is, can the company turn a profit? Boston Dynamics was founded in 1992 by Mark Raybert. The company was an offshoot of Raybert's work on dynamic robots at Carnegie Mellon and MIT. Early on, much of Boston Dynamics' research and development was funded by the US military and DARPA. In addition to robots, Boston Dynamics also developed 3D computer simulation software.
This robot, LS3, was part of a project that we worked with DARPA and the Marines. This was a proof of concept project to show that the robot could actually carry equipment in a useful way for a Marine squad.
Some of Boston Dynamics' other early creations included Big Dog, which, like LS3, was meant to traverse rough terrain and help soldiers carry gear, and Cheetah, which, at its fastest, could reach speeds of 28.3 miles per hour. Petman was one of the company's first humanoid robots. It was developed for the US Army to test the special clothing used by soldiers for protection against chemical warfare agents.
We're very proud of our history that involved DARPA and government funding for creating some of the fundamental technology. It was really that visionary funding that sustained over long periods of time that was required to solve truly hard problems.
But in 2013, the company's focus shifted after Boston Dynamics was purchased by a well-known technology behemoth.
What does a Big Dog, Wildcat, and Cheetah have in common? While it may sound like the beginning of a joke, those are the names of robots by Boston Dynamics. Google continues its recent string of acquisitions with engineering company whose repertoire includes designing research robots for the Pentagon.
When Google purchased Boston Dynamics for an undisclosed amount, the internet giant was gobbling up robotics companies left and right.
The New York Times first reported the acquisition, noting that it is the 8th robotics company Google has bought in just the last 6 months. There is speculation that Google wants to build a new class of robots that could perhaps do everything from warehouse work to package delivery.
At that time, Google was a bit more ambitious, and they are trying to look for the sort of next big thing. And highly specialized robotics is sort of perceived as a big emerging area that the industry was sort of expecting or anticipating at that time.
Google itself did not say much about the acquisition, other than that it would honor Boston Dynamics' existing military contracts, but was not interested in becoming a military contractor itself.
I think there are some concerns around Google dabbling with military contracts. They might hurt their public reputation.
But without government contracts, Boston Dynamics would lose its revenue stream. Even existing contracts that the company had with the military did not always pan out. And R&D was expensive. Owning Boston Dynamics reportedly cost Google $50 million a year. Internal movement at the company also shook things up. When Google bought Boston Dynamics, its robotics effort was being run by Andy Rubin, who was well known at the company for leading the development of Android. But after Rubin left Google in 2014, Google's robotics division stalled. Then in 2015, Google, which by then was renamed to Alphabet, got a new CFO, Ruth Porat. Over the next few years, Porat went on a cost-cutting spree, and Boston Dynamics was one of the casualties.
That relationship didn't really last very long, mainly because the fruit of that relationship is not as big as what Google perceived it to be.
Boston Dynamics again found itself with a new owner.
SoftBank adding to its artificial intelligence portfolio by buying robot makers Boston Dynamics and Tokyo-based Shaft.
Once that company moved on to SoftBank tried to inject more of a commercial DNA into the startup itself.
When SoftBank purchased Boston Dynamics in 2017 for a reported $165 million, the Japanese conglomerate already had a few robotics companies in its portfolio, as well as a consumer robot known as Pepper.
The idea was for SoftBank was that it really wanted to become a large robotic supplier to the industry in general.
Under SoftBank, Boston Dynamics did open up sales to its first commercial product, Spot, in June of 2020. Prior to that, the inspection robot had only been available to lease as part of the company's early adopter program. But like Google before it, SoftBank found that breaking into the robotics market was harder than it seemed.
The market still largely concentrates around industrial robots as well as warehouse robots. So the robots type or form factors that Boston Dynamics excels in are not what market wanted at the end of the day.
In December of 2020, Boston Dynamics changed hands again. South Korean car company Hyundai announced that it was taking an 80% stake in Boston Dynamics to the tune of $880 million.
This year, tens of thousands of robots will be built and put to work out in the world making money. But in the next 10 years, millions of robots will be built and get put to work in the world. And in most of these markets, no matter how big they are, a small number of companies end up dominating a majority of the market share. And so I think Hyundai is positioning itself to be the leading robot manufacturer.
Hyundai bought us for our mission. They're excited about our mission to launch novel robots that can help industry. And ultimately, I think they see their own mission evolving beyond cars to generalize mobility and see the things that we've been developing as ultimately complementing them.
Hyundai and Boston Dynamics are still far from dominating the robotics market, but it's a market with a lot of potential. Revenue from mobile robots in the warehouse, manufacturing, and infrastructure spaces is expected to increase dramatically, from about $6.1 billion in 2020 to about $64.9 billion by 2030.
Something like 800 million containers are shipped around the world each year. Many of those are full of boxes. There's probably trillions of boxes that are loaded and unloaded by hand each year in the United States. It's a huge job. It's a mountain of material that has to get moved. Stretch is really power tools to help people move that material.
Stretch is made up of a few different parts. The robot uses a mobile base to move around tight spaces and go up loading ramps. An arm, gripper, vision cameras, and sensors allow the robot to identify and handle a variety of different objects.
We're starting with truck unloading, but we think truck loading, as well as what we call order building. So when you go through a warehouse and assemble a bunch of different boxes onto a pallet, that order building is a big job, and we're actually developing that at present. Similarly with Stretch, we're building in intelligence so that the robot can deal with unexpected conditions. If suddenly it knocks down a cascade of boxes, the robot can deal with that and pick them up and clean up its own mess.
How do you feel about competitors? There's Amazon that has their own robotics for warehouses.
There's a lot of automation companies that are entering the logistics space, And of course, the logistics space has a huge variety of problems to solve. We're uniquely focused on mobile box moving, which almost nobody else is looking at. So we think we have a nice, safe entry into that market that we can own for a significant portion of time.
Amazon, I think, is lighting terror in the hearts of all the warehouse owners across the world. So they have a very motivated buyer that wants to buy tech that's comparable to what Amazon is developing.
Boston Dynamics says it expects Stretch to go on sale next year, though it would not provide a price point. Customers can also opt to purchase just the computer vision software that powers Stretch, which Boston Dynamics calls PIC. The company says it's working with a few early adopters to test the robot, but would not say who those partners are. Unlike Stretch, Spot has already hit the market.
We've sold several hundred Spots thus far. We launched it really commercially just last year. The entry-level Spot Explorer is about $75,000. We have another version that has additional capability in a recharging station that's a little bit more than that. Sales have exceeded expectations, really.
Payloads like pan-tilt cameras and LiDAR are sold separately and can be quite pricey. Even so, Spot has received interest from a number of industries. So far, the robot has been used to do inspections at construction sites, oil rigs, nuclear plants, to check the vital signs of COVID-19 patients in hospitals, and even remind people to maintain social distance amid the pandemic.
So I would take a substation like this and subdivide it into maybe 4 sections, and I would have the robot do a detailed inspection on each of those 4 sections.
This is Dean Berlin. He is the lead technology analyst for National Grid, an electric and gas utility company that serves customers in Massachusetts, New York, and Rhode Island. For the past year and a half, Berlin and his team have been testing 2 Spot robots by programming them to do inspections of National Grid's equipment. Berlin says the team also considered other robots for the job, but chose Spot for its mobility capabilities.
Some of the advantages that we find for the Boston Dynamics robot is that because it's a 4-legged walking terrestrial robot, it can actually transverse our substations fairly easily. The robot also can be equipped with a variety of different payloads, making it mission specific.
So we're going to power on and undock the Enterprise robot.
A typical inspection looks something like this. First, engineers program Spot so that the robot knows where to go and what gauges to pay attention to. The instructions for each mission are relayed to the robot using a QR code. The robot that National Grid is using is equipped with LiDAR to help it navigate, as well as visual and thermal cameras to take detailed photos and thermal images of the equipment in the substation.
The robot will be focusing on switches and circuit breakers. It will also take zoomed-in visual images of some of the gauges on the equipment to monitor the levels of those gauges. It can use this information to diagnose if there are hot spots on our assets that might indicate areas of concern or areas that we might need to attend to in upcoming maintenance.
Prior to using Spot, most inspections at National Grid's substations were done by people. In some cases, operation of the substation would have been temporarily shut down, since it wouldn't have been safe for humans to do the inspections while the equipment was still on.
National Grid has noticed savings in terms of time because the robot is able to perform these missions in parallel to a human performing other tasks. So in a sense, you get efficiency from having a human and the robot operating at the same time.
Spot may even go to space. NASA has been sending teams of the robotic dogs into caves to see if they can one day be used to search for life on other planets. Caves' protection from cosmic rays and stable temperatures, NASA says, makes them the most likely of places to find life.
My team's focus at NASA is on developing next-generation AI and autonomy algorithms for robotic systems. Our solution, which we call it Nebula, that analyzes the terrain, analyzes the environment, and risk. In a certain sense, you can look at Nebula as a robot brain that we integrate with robot body that could be a wheeled rover, a legged platform, or even a flying drone.
In the case of exploring caves, Aga says his team chose Spot for several reasons.
You often come across narrow constrictions, narrow passages that you really want to be able to traverse with a system that is not large and bulky. And the Boston Dynamics robot offers an interesting combination of small size, at the same time high locomotion capabilities and enough power to be able to traverse through those sorts of narrow passages.
The ability for Spot to be equipped with different payloads also comes in handy. Sending in one large robot to carry all the scientific equipment needed for a mission would make navigation in the cave difficult. Instead, NASA sends in teams of Spot robots, which can each simultaneously accomplish different tasks. NASA says there are a number of things that need to be worked out before Spot can explore new planets, but the potential opportunities have scientists excited.
We have a region on Mars called Tharsis region. There are a lot of interesting caves that if we can explore one day, we will learn a tremendous amount of knowledge and we can get a lot of science from it, but it's highly uneven. That's where different and new locomotion ideas need to come in, and Legged platforms is one of those that can transform how we think about exploring.
Although demand for warehouse and inspection robots is expected to increase in the future, Boston Dynamics still faces a number of challenges on its road to commercialization, many of which the company has already been running into with its Spot robot.
Over the past 10 years or so, we've basically solved most of those fundamental research problems. And when things were working well enough, we started to ask, how can we make this practical and how can we start making this useful in real applications?
Manufacturing, having a service department, having a sales team, those have all been new skills for us. Marketing, all new things for us that have encouraged us to really expand our staff.
Plater says his team has grown from 100 employees during the R&D stage to 400 employees now. So far, Boston Dynamics says it's been able to keep up with demand, producing around 40 to 50 Spot robots a month with the help of contract manufacturers. Final testing, assembly, and repairs are done in-house. But in order to compete in the larger market and have a shot at profitability, experts say Boston Dynamics needs to seriously ramp up production.
Boston Dynamics' biggest challenge to commercialization today is just cost, pure and simple. The hardware itself is the other piece. The hardware itself for something like a Spot is today probably in the $20,000 ballpark. They've got a great robot, hugely technically capable right now, but that's far too expensive to really sell at huge scale today, because people's alternative is a robot that's not nearly as capable, but 1/5 the cost. And as long as it's capable enough, they're always going to go with that alternative.
Boston Dynamics hopes that's something else Hyundai can help with.
Hyundai is really going to be a great partner for this stage of commercialization because they bring expertise in manufacturing and obviously a worldwide footprint in sales and service. And those things are going to help us get our robots out into a broader audience.
In the inspection space, Spot will have to contend with wheeled inspection robots and flying inspection robots or drones. A number of companies, including Swiss-based Antibiotics and China-based Unitree Robotics, for example, are also making four-legged dog-like robots, though the latter seems to be marketed more as a human companion rather than an industry tool.
We do enjoy a pretty good lead in terms of the robots having reliable behavior in complex environments. Our robots have dramatically better integration between their vision systems and their balance systems. And we also do a lot of the higher level functions that you don't see our competitors doing, like complex mission planning and actually completing a lot of these end-use applications that produce value.
Spot's really the only robot in the world that can deal with the complexity of the terrain that people can.
Boston Dynamics faces just as much competition in the warehouse robot market, which includes companies like Six River Systems, Fetch Robotics, Gray Orange, and Geek Plus. And then, of course, there's Amazon.
The interesting part with Amazon when it comes to logistic business is that they tend to develop solutions just for themselves. Amazon doesn't really supply the technology to external parties. But then again, there definitely can be a competitor because at some point, Amazon may feel like they are ready to now serve the wider market, and then they can now roll out their solution.
In the end, some experts believe the market could be regionally segmented, with Western customers choosing Western robot manufacturers due to security concerns.
When you deploy a robotic solution into the field, it's also about collecting data. The current market perception is that if you were to go with the Western suppliers, in this case Boston Dynamics, there is a lot more respect towards how the data is being used.
Boston Dynamics says it's off to a good start. So I'm sure developing these products is very, one-time consuming and too costly. How are you covering the cost right now?
really through the investment of our owners, such as SoftBank and Hyundai. They're really covering the cost. Now we do have significant revenue at this point, which is also helping. We're generating revenue currently from the sales of our robots, primarily Spot. We have a little bit of time before we're profitable, but we're on a great trajectory so far.
As for its R&D roots, Boston Dynamics says it's not leaving those behind.
It's critical that we maintain leading-edge R&D work within the company as we commercialize. But we've only covered a fraction of what we need to do with robotics. There's additional work in vision and manipulation that we want next-generation robots to have that we currently can't do. So it's important to keep pushing that forefront.
Plater says the company is also looking at other industries, including construction, manufacturing, and entertainment. As for Atlas, it will likely remain in the lab.
Could we see Atlas doing parkour with us in our backyards someday?
I do think robots will ultimately have relationships with their owners that could be rewarding and interesting. I don't see Atlas as being that product. I hope in the long run, robots aren't the exception. Instead, they become the rule and that we're all comfortable around them and they delight us and enhance our productivity and safety.